Okay, so the front panel layout here on the PRO-TEC 200 AC/DC. Let's start with the orange buttons. So these orange buttons are our primary control of the system. Start over the right side, we have a picture of a TIG torch. So the TIG torch there, we push the button and it says 2T or 4T. So we're using 2T, which means trigger on, trigger off. We then have current selection, AC or DC. It's currently on DC. If we push the button, we'd change to AC. If we were down here, we would turn on the stick electrode process, which I won't do because it'll turn the fan on right now. But if we wanted to do stick welding off this system, we could. We just hit that button there for the stick welding process. Over this side, we have gas purge. So if I push that button, we will purge our gas. We have high frequency. So if we wanted the arc starting to be not a touch start, we wanted a HF high frequency start, we'd push that button and activate that. And lastly, we have this symbol here, which is a symbol for pulse welding. So if we turn pulse on, that means we'll have a pulsed output current. I'll turn that back off for the moment. So what we have now on the orange buttons you'll see is TIG process 2T, DC output with a HF start. You then have this main controller here. This is the control that drives the whole system, and you'll see I'll scroll through this line here with all dots across it, and what that is the whole welding process sequence from the start when you push the button with pre-gas flow right through to the end of the weld where you'll have post-gas flow. And the important thing to note here is whatever you activate with your primary control, you can only then make adjustments with these secondary controls based off what you've selected. So if you select pulse, well, you'll then have ability to change pulse parameters. If you select AC, you'll then have the ability to change wave balance and pulse frequency controls, which we'll get to a little bit later when we look at the AC welding. Okay, so if I turn this around now, let's look at the sequence. We start here, when we first start welding, we've got a gas cylinder, and this will time out. So if I push that button, the light will flash. I can now change that parameter. And what you'll see here, these parameters are either in seconds, they're a percentage, a hertz frequency number, or it could be an amperage or a voltage number. So in this case, I have a pre-gas flow of, in seconds, 0.1 of a second, and that's pretty normal to have a very low pre-gas flow there, because I've only got a standard length torch, so I don't need much pre-gas flow at all. That just gives 0.1 of a second there, what I've set that at, to purge the gas line through the torch before the arc will actually start. Okay, I then go to my next one here, which is this one, which is in seconds. So this could give me now a time between where I'm starting my start current, which is 10 amps, up to what my weld current would be. So if I want to set 1 second, there is an example, and then I set my weld current here at 100 amps, what would then happen is between where I was starting at my start current level, it would take 1 second to ramp up to my weld current of 100 amps. Okay, if I don't want that, I can just turn that back to 0, and then what would happen is as soon as I push the torch button, I'd go straight to 100 amps pretty much instantaneously. If we keep moving through the sequence here, we then go to downslope time. The same thing. I might want a downslope for 3 or 4, let's say 4 seconds. I push the button, so now what will happen is from my welding current of 100 amps down to the end of my weld, it will take 4 seconds to ramp down at a controlled rate. Every second it'll drop weld current down to where I want to finish. Now, if I had more advanced things like a foot controller, I'd control that myself anyway. So I'll turn that back to 0 there. Then post gas flow, the last part of the sequence when we finish welding, and this actually is really important because it does two things. One, it shields the weld pool at the end of the weld. Secondly, it also shields the tungsten electrode in the torch. Now, you know, a tip here, if you are welding, the higher the welding current, the longer the post gas flow time should be. Anything up to 10 seconds is good. That really shields and protects, one, that weld pool when you finish welding, and two, the tungsten electrode from getting contaminated while it's still very, very hot. Okay, so primary control on the orange buttons by process, by current type, pulse, etc. Secondary parameters adjusted here through this sequence, and they're in seconds, percentage, hertz, amps or volts as secondary parameters, and this is your main controller that drives the system. You push the button, make adjustment, and make the setting, and then it's locked in.